Hello, I'm back again. I'm hoping that this is going to be the last video that I'm going to have to do on this particular project. It's again, it's a continuation of the new tailstock and trying to solve the error that I have on the quill between the headstock spindle and the tailstock quill. In the previous video I had an error. It seemed to be okay in this plane on the center, but I had a slope going down or going up, I think it was. Yeah, I can't remember now, but anyway, I've been fiddling around with it again this evening, and I don't know, I had it, let's see if I can get that round there and show you. I had it on the surface table over there, and I checked it with two nice ground blocks and adjustable height or slips or whatever, and I couldn't find much wrong with it. The only thing that I could really find wrong was that the underneath of the two plates on, swing it round again, and where are we here? Yeah, I had a little bit of a discrepancy on the top surface of the two plates that were on either side of the female dovetail, and there was a slight slope on it. Then I got my little dial indicator stand. It's a Starrett. Where are we here? Yeah, it's a little Starrett. Don't know what number it is. There's not much you can see on there. Nice little Starrett. And what it has is it has a little plate that slides along the base, and I thought, well, instead of when I was checking it yesterday on the previous video, I had it placed on the cross slide surface, and it occurred to me that maybe when this was all machined and fitted, the saddle with the cross slide, there was the possibility that it wasn't exactly level with the bed, and although it runs nice, I thought, well, why am I doing it off of here? Maybe I should be coming off of here. And I did. I used this little unit, and had a dial indicator on there, and I started checking the quill off of here, like so, and using this edge. I found that by doing that along this edge, I found that there was a run out on this face, which meant that it was like this tailstock was kind of skewed just a little bit, And so then I thought to myself, well, maybe this is not quite right. There may be a little bit of a error on there. So I reverted back to the saddle and cross slide, and I did it without moving. Once I got it set, I did it without moving the cross slide, only just using the saddle to move along, because that's, regardless of whether this edge is perfect or not, I don't know, everything is machined from the saddle. And I thought, well, I must be doing it from the saddle, because that's the way that the lathe is machining. Regardless of the bed, it's the saddle that moves along. So I decided to check it again with this unit here. So, and I have checked it, and it's really quite good. I moved the sliding block with the tailstock on it to several different places and locked it up again, and I got the same results. So then I thought, well, maybe the headstock is not quite straight, and so I decided to check the headstock, and that's what I've just done. I got this running, I'll put this on here like that. That's on 0, and I got running about 2 thou out at this point. Oh, it's a little bit over 2 thou, maybe 2.5 thou. So I figured, well, I'm really concerned whether the pin is running true on the center. So I switched it off, and I'll just move this again and bring it up to 0. I hope you can see this. I noticed on the other video that when I used the flashlight, it didn't work very well. So I'll just move that backwards and forwards and 0 it. Okay, now bearing in mind that this is running 2 thou out, so it's running 1 thou off center. So I checked it, and as you can see, it's half a thou there, and I'll move it round, say 1/4, and it's on the 1 now, and you see that's like perfect all the way along. Now that's, I don't know what that is, I don't know, a couple of inches, I guess. So then I turned it again a little bit, you see, to 2, and I run it again, and it's still on 2. So it's not actually really bad. Certainly good enough, I think. I'll go back to 0, and there's a half-hour run, but this is a dowel. It's a hardened dowel that I've got in there, 3/8 diameter. Well, maybe it's not perfect. You know, it's just a dowel, and I don't have anything else that I can run through unless I put a 3-jaw on or a 4-jaw and do it that way. But I mean, I'm just looking for half a thou or a thou, and you know, it's not space equipment, so I figure that that's okay. So what I'll do now is I'll lift this up, and we'll bring it over to the quill. Now I've got it out, I've got the quill out as far as I figure is as much as I'm ever going to have it out there. So I'll just lock it up now, and again I can only get down so far. I can't get right down on the very highest point because I have this slot in here. So all I can do is to try and get it on close to the slot. Maybe I've got to... This takes a little bit of time because it... Let's see if I can... No, that's no good. It's got to be that way, I guess. I don't think that's any good that way. Or maybe it is. Maybe you'll be able to see. Just twist it round. And wind it in. I'll try and get it down as low as I can to the slot. It needs to come up a bit. Come on. Well, it should be on there. There we go. So now we have it on 0, and I don't think it's in the slot, so we'll run that back there. Now I hope you can see this. Where are we there? Around a bit. Okay. Maybe like that. If I hold it like that, you'll be able to see it. Okay. Well, it's not quite on the 0. Okay, that's it. Okay. So now I'll run it and we'll see where it is. Half a thou is 0. Now it goes to minus. And it's a thou. Oh, what did I do? Oh, I went off. Did I? What did I do? That's 0. Huh. Maybe I'm still on the slot. Just lift it up a bit. Okay, so now, as you can see, it's maybe 3/4 of a thou. It's dropped down to 0 and it's gone down to 0 again. So in all respects it's really not bad in that plane. So I'll undo it and wind this back, and I'll pull it in, and as you can see it goes a bit off there, because like this is a piece of cast iron. I did it in my I machined it in my my Myford lathe that I had, my Drummond, and I had to you know, I bored this out on the lathe here between centres with a boring bar in between. So I bored this hole out with this thing strapped onto the, you'll probably see it in one of the videos, or maybe several, but I strapped it onto the cross slide, and I had to get it square and bore out the hole for the quill. And then when I machined the quill in the Drummond, there's some little, you can feel some little tight, not tight spots, but high spots, I guess you'd call it. And so this quill is not perfect, because to get it fit in nicely I had to use a little bit of emery paper, emery cloth, and spend some time getting it fitted nicely. You know, I did, other than this quill, everything else was done on the Taig equipment, and this was all done on the Taig. The bore in here was done on the Taig. That was quite a thing, you know, getting it set up and clamped onto the cross slide. So there's some, the quill, the outside diameter of the quill is not exactly like ground all the way along perfect. There's a few high spots there. So maybe when the stylus goes along there, it hits the little wavy kind of, you know, I'm talking about maybe a quarter of a thou difference. And so I think that's going to be okay. So that's that way. Now I'll do the top. I think this is how I did it. Oh, no, that way. Yeah. Yeah. Bring the stylus up. Damn. Like that. That's it. Like that. Fiddly, eh? Okay, we'll come down, get a reading, and we'll wind it, find the high spot. We'll go up that high so you can see the needle. Okay, find the high spot. Okay, that's the high spot. Now, if you look at that, that is pretty good. So, something's happened here. I don't know what's happened, but it seems to be pretty good now, as you can see. there's a thou. Well, that's not bad, because that really doesn't matter too much when you're turning between centres. You adjust it this way accordingly so you don't get a taper, and I think maybe half a thou slope between the centres is not going to have any effect on the diameter that you're machining. So I'm going to leave it at that. I can keep on messing around with this thing and still get the same results. So I think, to all intents and purposes, this thing is finished now. While I'm here, I'll just show you when I mentioned in a previous video about putting pressure on and this moving. Well, that was when I had it bolted down through the top there, and the dovetail was like fixed, so there was some slop there. So one of the things that I did to compensate for that was to, like I say, come on, there you go. So I had this block. Now what's happening? That's supposed to go on. Okay, that's it. So what I do is, if I'm drilling, I don't bother. But if I'm going to do anything by using the centre and I'm machining something and I want it parallel, then I put this on, tighten the sides up, lock it on there, and then I just get this and slide it on, do up the 2 screws here, and that supports the pressure that's applied and stops it from, and keeps it from moving, stops it from moving. So that's just another thing that I had to do to compensate for the errors on this. I'm not saying it's perfect, but it is handy, because like if you realize, I'll take this out now. If you realize the let's see, before, with the standard tailstock, this thing hits the tailstock and you've got your centre sticking out here about that far from the face of the original tailstock, which it's only 1/2 inch anyway. There's no support there really, hardly any support there at all really. And I found that in doing this job here, this tailstock, I had to, because this saddle is so wide and the tailstock is so short, it doesn't overlap the cross slide at all. I found that I had to keep on moving this from this slot over to this one to finish off, and of course you lose your settings and God knows what else. So with this I can let's see, I can have the tool in the front or the back, whichever way, and that allows me to bring the tool right the way back, away past the center, revolving center, and I don't have to move anything. So and also when this is not on here, if I'm doing drilling or something like that, and then I want to move the saddle out, I can move it right away underneath, and it's not interfering with anything. Likewise, if I'm up here and I want to drill, I can move this. Right the way along over and get way past the saddle, and just use a short part of the quill to move in and out. So it does work. It's not perfect, but it does work, and it does a pretty good job. You can see that I'm drilling 7/16 with a 7/16 drill bit with the one Morse taper in there, and it does it quite well, especially on these little belts. So that's my next job. I've ordered 2 sets of the new CNC pulleys on the Tailstock CNC machine, and it's I think they're 3mm belt with 4-step pulleys on both motor and the spindle, and I'm hoping that will give me a lot more torque. I don't know exactly what power that Sherline DC motor is, but I'm hoping it's going to give me more power at the lower end without slipping. So that's about it. I guess another video done. Bit long-winded, I know, but that's all I can do. So I'll call off now, and thanks for watching the videos, and I guess I'll see you next time. Okay, thank you.